Okay, 3 is probably the one I understood the most. Using partial fraction expansion, you start with big X of S, you're trying to get to little x of t. So you can factor out this denominator using alphas as the placeholders for the numerators, and you can then factor that out. And if you set S equals to -2, so alpha 2 and 3 disappear, you can solve for alpha 1, which is 1. Do the same thing for alpha 2 and 3, -6 and 6. Plug that back into what you had up here. You can use the Laplace transformations to get little x of t equals e to -2t minus 6e to -3t plus 6e to -4t. For part B, you can also factor out the denominator. Since this was squared, you have alpha 1 all over s plus 1 plus alpha 2 all over s plus 1, the whole denominator squared. Factor that out again. You can set s equals to -1 to get alpha 2 equals 1. And you can plug this back into this equation and then set s equals to -2 to solve for alpha 1, which is 1. Plug that back in and then use Laplace transformations. You get x of t equals e to -t plus t e to -t. For part C, you have to factor again, but it doesn't factor very nicely. So you end up with j's. If you set s equals to -1/2 minus square root of 3 over 2j, then you can plug that back into this guy. And then you can get alpha 1 equals 0 and beta 1 equals square root of 3 over 3. Plug these numbers back into this guy, and then use Laplace transformations. You get 2 square root of 3 over 3 times e to -1/2 t sine of square root of 3 over 2t. And then for part D, you can split into 2 different parts. You can factor out this one over here and then multiply it by e to the -0.5s. You can use the same s equals 0 and the same strategies to get all the coefficients at the top. Plug that back in and then Laplace it. You get 1/2 minus 3/4 e to -4 times t minus 0.5. All of that plus 2/3 e to -3 times t minus 0.5, and that whole thing multiplied by s times t minus 0.5 that you got from this e. The one that I understood the least was number 1. We're looking at the time required to achieve 90% conversion of the substrate. Since we're looking at batch, feed equals 0 because we don't have a continuous stream of feed. This is the reaction growth rate. It took me a minute to realize that this is referring to another part in the textbook, so I was confused for a while. But if X is the mass of this is the mass concentration of the new cells, and then P is the product concentration, and S is the substrate. Um, um, and then we can solve for mass balances for X, P, and S. And since volume is constant, this derivative all goes to 0, and then here this F goes to 0. And then you can use this system of equations. I did not use the um, program that you used. I used Python, but I got the same time. So, yay!